I have the signal generator hooked up to the modulator directly where I'm bypassing the microphone amplifier. So I've popped the 1 microfarad loose, that's the coupling cap, out of the microphone amplifier. And I've set this up here, and right now I'm modulating with around 1200 hertz. You can see the large spike is the upper sideband. Here is the harmonic of the modulation frequency, second harmonic, here's third harmonic. Right now it's down 10, 20, 30, 40 dB down. That's down pretty good, and change in frequency really doesn't appear to change the amplitude of it too much. What's hard to compare is drive levels though. So if we look over here, at the scope right now I have about 1.5 volts out of the transceiver. So we can compare that drive level with 1.5 volts later on when we go back to the microphone amplifier to see what the amount of second harmonic problem is with it with 1.5 volts of drive level. So I'm going to increase the drive modulation voltage, and I'm getting an increase in amplitude of just about everything, but right now I'm driving it pretty hard. This is the sideband, this is the carrier, this is the lower sideband. We could adjust a lot of that carrier out, I believe. No, I think I'm probably driving it too hard right now. And if we look at the scope, we have over 2 volts output. So that's probably driving it too hard. I'm going to drop back down to where I'd get 2 volts output. There's 2 volts peak to peak there. And the spectrum analyzer is showing 30 dB of suppression for that second harmonic, and it's showing 40 dB of carrier suppression. Carrier suppression could probably be tweaked a little bit. See there, it dropped down to about 50 or 60 dB down. So there we have, with 2 volts output, we have 30 dB of suppression on that harmonic, second harmonic. We'll hook the microphone amplifier back in now, and we'll take a look at the same thing. I have the microphone amplifier hooked back up, and I'm running with 1.5 volts peak-to-peak output out of the exciter, and we can look here, and I've got about 30 dB of difference between the upper sideband and that second harmonic. So let's increase the amplitude until we get to 2 volts of output and see what that does to us. Okay, there we have 2 volts of output, and we only have about just a little over 20 dB right now. So, and we're only getting about 20 dB of suppression now. So that tells me the microphone amplifier is contributing to the harmonic distortion fairly significantly. So that tells me I need to look at that circuit a little closer to see if I can figure out the problem there. This is with 2800 hertz modulation, using the function generator as a modulator directly and eliminating the microphone amplifier. And what I like here is I have a lot of carrier suppression. This is the carrier down here. So we have 10, 20, 30, 40, 45, over 45 dB of carrier suppression there. So that looks good. I'm going to decrease the frequency now. And you'll see the upper sideband coming down in frequency. Towards the carrier. And there is 500 hertz modulation. This is the lower sideband here. See, it's starting to come back up into the filter, lower skirt of the filter there. So we'll increase the modulation. Here's at 1 kilohertz. You notice here's second harmonic of the modulation. This be the third harmonic. This is the lower sideband. We have 10, 20, 30, almost 40 dB of suppression for the lower sideband. Carriers right here. Second harmonic of the modulation there. Third harmonic. So everything looks good there. This is with 2 volts output on the exciter board into an open circuit, and everything is attenuated more than 30 dB. The carrier's more than 40 dB. So if this is enough drive for the linear, this should work okay.